actually should be getting fairly easier or feel easier because we're building on concepts that we've already learned, and we're just kind of adding a couple of small things to it. We've already learned about vectors, right? And that's my left-right direction, my up-down direction, and showing that in vector notation. You should remember, like, let's say I have a given point, and I'm going 3 to the right, 2 down, right? 1, 2, 3, 2 down. I would get something like that. And so if I wanted to show that in component form, 2 to the right, 3 down would look like that. Does that make sense? Do we remember that? Okay, that's that component form of the vector. So what we're going to do today is we're going to add vectors, okay, to come up with new vectors. So we've added vectors that are in the same or opposite directions, but how are vectors added when their directions are not so simple? There are two commonly used methods for adding any two vectors together, and I'm going to show those to you. There's two methods. The first method is what is called the parallelogram method. It's not my favorite method. I think it requires a lot more work, and it's going to come to the same answer, but I'll at least show it to you. The parallelogram method is a method of adding two vectors by drawing a parallelogram, using the vectors as two of the consecutive sides. The sum is a vector along the diagonal of the parallelogram. So if we had vector W, okay, which starts from here and goes up, and any two vectors I can start from the same position because there's no requirement for where one starts at, right, and goes to there. And I got vector W starts here, and I wanted to add those two things together. What I would end up creating is from the end of vector W, I would basically do vector V again. So whatever V was, so let's say V was to the right 3, up 3. Okay, then I'm going to the right 3, up 3, that's going to create a parallel vector, right? From the end of vector V, I would add on vector W. That's going to get me another parallel line because it's going to be parallel to W because it's going to have the same rise and the same run. Does that make sense? So the parallel line that runs through here is the new vector, okay? So if I see from this starting point how far to the right I'm going, okay, and how far up I'm going to be able to write the component form of that vector. Okay, it requires, a sheet of graph paper, but it's not impossible to do, and we'll see some of that throughout here. Okay, what to me is much easier, and granted, what they want you to know is the diagonal is the resultant vector, and that's their terminology. Two vectors or more added together is what is called the resultant. All right. The easier method, even though it looks like a whole lot of writing here, is what is called the head-to-tail method. And it's a method of adding two vectors by placing the tail of the second vector on the head of the first vector. The sum of is the vector drawn from the tail of the first vector to the head of the second vector, so on and so forth. One benefit of using this method is that while the parallelogram method can be used to add two vectors, the head-to-tail method can be used to add any number of vectors. I could add 10 vectors together if I wanted to. But in the parallelogram method, I can only ever add two vectors together. Okay? I'm going to show you an example of the head-to-tail method, and I feel like we've already done this. I feel like we've seen this before. But if I have three vectors in component form where it's 5, 4, -2, 3, -1, -1, I can add these together. Now, the thing to remember is that my y components can only be added together, and my x components can only be added together. Okay, I can only add y's to y's and x's to x's. So 4 plus 3 plus -1, okay, 4 plus 3 is 7, minus 1 is 6, right? All right, 5 plus -2 plus -1, well, that's going to be 3, minus 1 is 2, so the final component form, okay, or final vector, resultant vector is 2, 6. So the reason we want to keep these things separate is because if I added them together, let's say this lower one down here, for whatever reason, had been 9, positive 9. 4 plus 3 plus 9 is what? 13. Is it 16? Yeah, all right, because I got 7 plus 9 is 16. All right, it's not like I'm going to put a 6 here and then put a 1 up there and add it on. All right? What I want you to understand is that my answer would be 2, 16. Okay? So it's going to go 2 to the right, and it's going to go 16 up. So you have to keep your x's and your y's separate. Does that make sense? Okay. All right, so let's real quickly try to get through a few questions here. All right, here we want to add, and they're not telling me how to add these vectors, so I would say whenever and however possible, use the head-to-tail method. All right, so I'll do this first one. You guys can do the second one on your own. But there we go. -4, 3. Okay. 2, -9, and 7, 5. Okay. 3 plus -9 is what? -6. What's -6 plus 5? -1. Okay. What's -4 plus 2? What's -2 plus 7? 5. All right, so I should get 5, -1. I'll get that right there. Does this make sense? Does this seem pretty easy? All I'm doing is adding today, right? That'll feel like a pretty good day. Okay? Let's see. I want you guys to work out number 2. Let me know when you've got an answer. What do you got, Caleb? A, 2, -6. What's -2 plus -4? -6. What's 8 plus -6? 2. Right, giving me that guy right there. Okay, now we are, and we can, if I can clear this out, we can apply vectors to real world problems. Okay, a private airplane travels due north, okay, at a speed of 135 miles per hour. There is a 30-mile-an-hour wind blowing due west. What is the plane's actual speed? If necessary, round your answer to the nearest tenth. What's nice about this is that the resultant vector is this guy right here. Okay? So what have I formed there? A right triangle. So how do I find my blue line? Pythagorean theorem. So I'm going to do what? Okay. 30 squared should be what? 900? 900. Okay. 135 squared. It's like, what, 18,225, just off the top of my head. Okay. What's 900 plus 18,225? Something like, I don't know, 19,125? 19,125. Okay, what's my final step here? Square root of 19,125 comes out to 138.3 miles per hour. Okay, it's not too bad, right? So what we actually find is that if he's traveling due north and that wind is, even though it's pushing him west, it's actually increasing his speed, right? It's actually increasing his speed by 3.3 miles per hour, even though it's pushing him from the side. Let's see. Okay. At least according to this math. All right, number 4, use a parallelogram method. Let's not say we did. That's okay. We don't need to really get a coordinate plane out here, just because in the end, right, if I see something like this on the ACT, am I going to take the time to pull out a coordinate plane and do the parallelogram method? Probably not. Okay. Now, I could, we could make it, where we're doing something along those lines, but, really, to do this, we would do what? 3, 4. So start here, 1, 2, 3, down 4, 1, 2, 3, 4. That's going to bring me down there. 2, 2. I want to start from the same spot. So I'm going right 2, up to. That's going to bring me to like here, and I'm not going to, just by doing this, I'm not going to get an exact deal. So I would go up to, over to, here I'm going to come down, and then what I'm going to actually be looking for is I'm going to be looking for that line there. So, and I don't know how accurate my lines are there. You'd have to get a coordinate plane out. But let's see what we would get in terms of just using head to tail. 5, negative 2, so 3 and then negative 2. All right, so 1, 2, 3, 4, 5, 1, 2. So, I mean, we do see how it actually did come out about right, even just doing it by hand, correct? Okay. So 5, negative 2. Okay, let's look at this guy, I think. Yeah, we're like 8 questions, so 5. Hot air balloon traveled a horizontal distance that can be represented by the vector 3050, 0. Okay, that means if it's just going a horizontal distance, it's going to the right on a plane, 3050, but it's not going up or down. And a vertical distance can be represented by the vector 0, meaning I'm not going left or right, but I am going up 400, where the magnitude of both vectors is measured in feet. What is the magnitude of the distance of the balloon has traveled? So, in the end, because I'm adding 0 to both numbers, I end up with 3050, 400, right? Okay, so this is telling me I'm going 3050 to the right, and I'm going 400 up. The magnitude is the distance of that vector. So what do I end up using? Pythagorean theorem. So I end up, end up using those. So I'm doing 3050 squared plus 400 squared, and I'm square rooting that answer, right? Okay, can we tell me what you're going to get? Some of you are working it out. Miss out when you get an answer there. And I got 0.12, so there might be, whatever. 0.12, and that's feet. Right, so do we see how to use that resultant vector and then find the magnitude of the resultant? Okay. All right. All right, and our next one, number 6. Again, we should be getting used to this. Let's do the left-hand side. What's 13 plus 10? 23 minus 3? 20. Okay. Negative 12 plus 14? 2. 2 plus negative 4? Negative 2. Okay, so 20, negative 2. We've got this. Like we're at. The only 2 things that we've really done here today are adding things and Pythagorean theorem. All right, 7 and 8, and then we're out of this. Add the vectors, 0, 6, 10, 0, and find the magnitude and angle from the horizontal of the resultant vector around your answer to the nearest chance. So this does add a couple of things. Well, let's go ahead and add the vectors first off. 10 and 6, right? 10, 6. Okay, so we added the vectors. Next thing we want to do is find the magnitude. How do I do that? Pythagorean theorem, 10 squared plus 6 squared. So I've got 100 plus 36. What's the square root of 136? 11.7. Okay. It's probably like 11.66, is that right? All right, so I'm going to take it as 11.66. All right, the next thing that it wanted is it wanted to know the angle from the horizontal of the resultant vector. So what I'm going to do, okay, well, actually, I'm going to change this around, all right, because the resultant vector was 10, 6, right? So that means I'm going to the right, 10, up, 6. So I'm going to get something that looks like this. Is that correct? Okay. We want to know, what is this angle from the horizontal? Okay, from the horizontal. How do I find that? I want the angle though. Go back to yesterday's lesson. You're right with tangent, but more specifically, inverse tangent. Okay, what am I going to type in? 6/10. So somebody with your graphing calculator, what is inverse tan 6/10? What is it? Or be more specific, take it to the 2 decimal places. 30.96 degrees. Okay, because it says round your answers to the nearest hundredth. That's why we did 11.66. That's why we did 30.96. You understand what we're doing there? Okay? All right, so what I'm going to do is I'm going to hit stop on the video, but I want you guys to do number 8. I'll walk around. As soon as you have an answer for number 8, I'll let you get started on your homework.